space. And here's why I think you should too. Here are just some awesome, fun space facts I think are pretty cool. So a lot of astronomers theorize, and we actually confirmed this just like last year, that there is a supermassive black hole at the heart of every galaxy. I think that's so insane, pretty cool. Right here, if you guys see, Sagittarius A was actually, we were able to capture a picture of our supermassive black hole in the center of the Milky Way. The Event Horizon Telescope team were able to do this. They were also the ones who captured the first image of the black hole we had seen a couple years ago. The universe has the same temperature everywhere. I just think that's so crazy, just knowing how massive the universe is. We were able to actually figure this out by the cosmic microwave background. 95% of our universe is invisible. So sort of like that mass energy we interact with, we see every day, only accounts for about 5%. So 95%, which is dark matter or dark energy, we don't know what that is. That's why we call it dark. Yeah, scientists are very creative with their naming conventions, but yeah, we don't really know what it is. It's just insane that we just theorize that it exists based on what we know. Also, the universe has repulsive gravity, which sounds pretty weird, but we actually theorize this might be because of that dark energy. We still don't understand that well, but essentially everything is moving away from each other. This is pretty sad to me because if that holds true, that would mean we might not be able to see stars and galaxies up in the sky one day. But yeah, all of this is pretty cool. So I actually want to ask you guys, can you guys share an aspect of space science or space that you guys find interesting in the chat? Anything? It doesn't have to be super like impressive, just anything. Your favorite planet, if you don't have anything. My favorite planet is Venus. Your favorite planet is Earth. Pretty solid, our home planet. How big the universe is, yeah. And we can only really see like the observable universe. There's a whole other side of the universe we just know exists, but we can't really interact with. The absolute scale of it, theory of everything. Okay, I'm seeing some astronomers in the chat. Some of the dwarf planets have cool names, very true. The Kerbal planet, I love like when we like astronomers give like actual names instead of like Z74534. Like I think like cool names with like stories behind them are pretty cool. But okay, yeah, so why I was kind of asking that, there's so much out there that we have yet to explore, understand, work with. And what does this have to do with AI? Because this is an AI course, right? Like what does this have to do with AI? There's so much just information out there, kind of like we predict that in our observable universe, we have these many stars. We have this dark energy, dark matter that we don't understand, but we know exists. There's just so much information out there that there's so much application for AI. And a very impressive software to help us and help astronomers kind of handle this data. So what we're going to go over in this kind of presentation are the fields of AI in the space sciences. So I'm going to go over some of the fields that you guys have seen before. So computer vision, neural nets, natural language processing. There are a lot more fields, but I'll kind of go over the ones you guys have interacted with in the last couple of weeks or so. Yeah, let's just get into it. So I'm first going to go over computer vision. So here is a very cool mission that is going to be launched in October 2024. They kind of predict for it to be launched around then. Then it's the Hera mission by the ESA, or the European Space Agency. And this is essentially a defense probe that's going to be launched by the ESA. They're working with NASA as well to collect some data from the Didymos binary asteroid system. So they're hoping to launch Hera. That's what their defense probe is called. What's cool about this and what this has to do with computer vision is that they're hoping for it to be totally autonomous, so that it will be completely self-driving. So they're taking a lot of the current software that exists in self-driving cars and hoping to like implement that in Hera. And yeah, that's pretty interesting. Like we're going to be seeing computer vision if this does come to fruition. It's going to have an asteroid framing camera, a lot of different types of inputs, a star tracker, laser altimeter, thermal infrared cameras, a lot of cool things, but it will be totally self-autonomous driving if that does happen. It's pretty interesting. Oh, if you guys are interested. In the chat. So for those who keep up with like NASA missions, I live in the States, so I love keeping up with sort of like our space agency's missions. This is Perseverance on the left. This was one of the first NASA rovers, if I'm not wrong, that was that used AutoNav, which basically meant it was also self-driving and autonomous and used very minimal input from people back on Earth. What was super cool about AutoNav was Perseverance was able to create 3D maps and essentially tell itself where it needs to go next, measure out obstacles, etc. And this also used computer vision. So that was able to do this. Pretty interesting and a pretty big field in space sciences currently. Here is another, I love this example because it's so cute. Let me see if I can share my audio. Great, okay. Basically, this is the int ball, or the cute floating Japanese camera on the ISS. This was created by the Japanese Space Agency, or JAXA, and essentially it is a cute little ball that floats around to help astronauts on the ISS. It takes pictures, it records things to help them, because a lot of the astronauts on there are constantly doing research, and a huge part of research is documenting it, right? So this essentially helps them to avoid kind of those like mundane tasks of recording everything. So I hope we can watch this. So pretty cool. Another example for computer vision. Okay. So just continuing on, I think this is our last computer vision slide, but this is an open source software that exists that you guys can use currently. It was developed by NASA. NASA should be all caps, that was my bad. But essentially it is an image processing software, also known as NASA's Vision Workbench. If you guys search that up, you guys are able to see kind of like the computer vision software that's used, but it is able to process a lot of satellite imagery, some 2D, 3D reconstruction. But yeah, something that you guys are able to actually work with. Okay, now moving on to neural nets. This is actually one of the projects that some of you might be working on, which is detecting exoplanets. So NASA actually paired up with Google to see if we can use neural networks to detect exoplanets just with all the data that exists. So essentially, there's a lot of flux or brightness data that people have to manually go through to see if there is a potential exoplanet in a star system. There's a lot of noise in that data when astronomers are kind of going through it. So they were hoping that maybe neural nets were able to go through some of that same data and find planets that maybe people were not able to observe. Here is a video just to explain that a bit more. So pretty cool. It's using Kepler telescope data, similar to people who might be doing the Planet Hunters project, and something that one of the lead engineers, I believe working on the neural net, said machine learning really shines in situations where there is so much data that humans can't search for it themselves. And I thought that was very true. So, okay, just moving on with neural nets. The French Space Agency, or CNES, worked with a company called Clemesi, where they essentially were trying to use neural nets to figure out fuel filling optimization. So most of the time to get rockets off the ground, there is a fuel known as liquid hydrogen, or LH2, which is pretty unpredictable to essentially model. So a lot of the time physicists and engineers will spend a good amount of the time modeling how this fuel might behave in the second phase. Wait, I'll send this to you guys a little bit more, but they're hoping that maybe they can use neural nets to try and avoid that kind of time-consuming mathematical modeling, and the physicists and engineers can focus on something else. So pretty cool. Here is something I find super interesting. I've done some research in this area as well. But essentially, this is trying to see if we can predict solar weather and if we can forecast space weather, essentially, or solar weather. The terms are interchangeable, using neural nets. So for those who might not know, space weather, solar weather is just like the Earth interacting with a lot of the insane plasma particles that our sun kind of spews out at us. So it can disturb our magnetic field and mess up some of the machinery we have up in space. So trying to predict sort of that space weather, solar weather can be pretty important for some of the machinery that we have. So that's something that's being researched and done currently. We currently have a 27-day forecast program that is able to tell us what solar weather or space weather we might encounter 27 days prior, which is pretty helpful. This is one of my favorites. So this is Simon. I just think the face is so funny. This is developed by the German Aerospace Center, or the DLR. And essentially this is an example of natural language processing. This is a pretty cool assistant for a lot of the astronauts up on the ISS, kind of like the infall we saw with JAXA. It's fully voice controlled. So a lot of the astronauts up on the ISS are kind of floating around. So it's super hard for them to go from one place to the other. So they're able to just kind of speak to Simon, and Simon is able to help them with instructions, whatever they're kind of needing at that moment. It's able to see, speak, hear, understand, and even fly. So pretty cool. Yeah. Oh, and I thought this was funny because I thought this emoji looks like his face. I don't know if anyone else sees it. I see it. But okay, I just thought I'd put that in there. But also just some other space agencies' involvement with AI. The UK Space Agency has funded a project that uses AI to detect buried archaeological remains from satellite imagery. Pretty cool. And the Italian Space Agency has even co-founded an AI-focused company. So a lot of involvement with space and AI, especially in today. If there are any questions, I'll be here to answer them in the chat, but I'm done for now. I'll pass it off to Kyla. Kayla, back